To the I code. Today we're going to take a look at 2360 longest cycle in the graph. It's a hard problem and let's get started. So I'll give you the idea of the problem first and then a little bit of intuition and then we'll go ahead and code it, right? So let's see. So you given a graph, director graph, and then they're asking for the longest cycle length into the graph. And if you do not have any cycle in the graph as it in this graph, then you return -1. So first thing to notice here, we're given the ages like this, right? So from 0 to third there is one age, from first to node 3, from node 1 to node 3 there is one age. We didn't get 1 to 3 as such, right? So what this says that all node will only have one age, right? Only one outgoing age, right? So 0 has only one outgoing, 1 has only outgoing, right? That's the one thing. So if one thing to note is only one outgoing, right? Out degree. Second, if it has only one out degree, then each node is going to be the part of only one cycle, right? There cannot be other cycle starting from 4, or 4 cannot be part of any other cycle because it has only one out degree, so there cannot be any other node. So node, because that's important, right? And so once we have seen this cycle, we don't want to go and check this cycle again. So this can be done in O of n, because as I said, each node is a only part of one cycle, right? So I don't want to check that again. Also now, but I can visit 3 twice, right? Because I'm starting from 0 initially, I can visit 3 once, twice, right? So that's when, if it is already in the visited set, then we don't want to visit it again. But to detect the cycle, we want to know that I'm going to visit 3 as well again to detect the cycle. So that's when we will keep track of the time, right? So at what time I visited this node, right? And then once we keep track of time, I then I know that okay, this cycle is detected. Once the cycle is detected, I'm going to add it into the visited set, right? And that's when we will not visit the same cycle once we start from 1. Does that make sense? Okay, great. So see, there would be one visited and then time, right? So when I'm starting from here, from 0, then time is going to be 0. When I'm starting here, time is going to be 1, 2, 3, and so far. So to detect the cycle, we're going to check if our enter time, whenever I entered in the cycle, enter time is less than the current time. If it is, then yeah, we have seen the cycle, right? So this is the same node with time 1, and then I'm at the node 3 again with time 1, 2, 3, 4, and 5, with time 5, right? So that's when I know there is a cycle. So that's what time will be used to detect cycle, right? And then visited will be used not to iterate whole cycle again, right? So when I start from 1, I'm not gonna iterate over 3 and go through the same cycle again because it's visited, right? So okay, I hope that makes sense. And then let's start coding. So we'll do the DFS. It's a pretty standard template, but generally in DFS what we do is as we iterate through the nodes, we go ahead and keep adding it in the scene set, right? But this time we'll iterate through the node, we'll do the whole cycle, we'll detect the whole cycle, and in after that cycle is detected, that's when we're gonna add it into scene set. Okay, so let's start. So this is n, which is number of nodes, so that's going to be length of edges, we have to return something, so I'm gonna do result -1. So this will keep track of longest length, so we'll keep updating it as we keep iterating over all the nodes, right? We need one visited set, we need one time set, right? I'm going to initialize this to n, and then this is a start time, right, which is going to be 0 initially. Now it's time to iterate over the nodes. So for, let's start with node in range of n, right? And now, so when I'm starting at 1 the second time, 0, 3, 2, 4, and again 3, and then I'm starting at 1, I do not want to start the DFS if it is in this visited, right? We'll only start the DFS if it is not seen already, right? So we check that that condition here. If not in seen, sorry, it should be visited. If not in visited, and what is not in visited? It's node. Okay. That's when we do the DFS on node, right? And this would return something. This would return the longest length, and we need to pick up the maximum of which is going to be result longest length, or the whatever the DFS of node returns, right? And that's going to be the result again. And in the end, we do is return res. So but before we do that, we need to keep track of the starting time, right? At what time we started, right? So enter time, so that's going to be enter time equal to t. So now let's go and define the DFS. So def DFS, and we'll take input as a node, and then again, now we have to check if node in visited, right? If node in visited or edges of node equals -1, we do is return -1. That means node is already in visited, and then we don't want to visit it again. And if node of edges is equals -1, then there is no out degree. In that case, we just return -1, right? This is our false or terminating condition. So now this is the time where we check for the condition where we have found the second node of the cycle, right? So how are we going to know that? So if node, so we're going to check if time of node is greater than the enter time, right? That's when we know it's a cycle, right? So let's try if enter time is less than or equal to time of node. And since we have already defined it to the n, right, we need to make sure that it's not n. So one before, so we want to make sure that we have updated it once before, right? So and time of node not equal to n. That's when we do is return the cycle length. And cycle length is going to be the t. Okay, we have to make this non-local t. So t, whatever is the time at that point, minus t of nodes. This is going to be time of node, right? And then now once if everything is done and none of this happened, then it's a normal node and we have to do the DFS, right? So that's when we first update the time of the current node, which is going to be t, and then I increment t because I'm going to go to the next node, t plus 1, and then we call DFS on the next node, which is going to be edges of node, right? Edges of node. And this is going to return something, so we have to take this into one variable, which is going to be result. Now once all of the DFS is done for the cycle, and then we return the minimum longest, whatever the length of the cycle. Once the cycle is done, that's when we do add into the visited, right? Visited.add, that's when we add node to the visited, and then in the end I'm gonna do is return result. Okay, and that is it pretty much. Yep. So let's check, let's run it. Accepts these two, 3 3 -1 -1. Let's submit it. Okay, there we go. Well, not so much effective, but yeah. Time complexity wise, I would say it's O of n, O of e, because we have to traverse all the O of n. So yeah, O of n, it's a constant memory. We are getting, no, it's a O of n, because we have the time array and then visited array, so it's O of n, time and memory complexity. And if you like the code, if you like the channel, please share and subscribe. Thanks a lot.